This is problem number 6 from section 7.1. In this problem, they want you to find the other trigonometric functions of theta. They give you sine theta equals -3/8, and secant theta is less than 0. Now, I always like to start by trying to figure out what quadrant are we in. So let's go ahead and draw the different quadrants. This is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. Now, we need to figure out where is sine at in these three quadrants. Well, we know sine, because it's negative, that means sine theta is less than 0, right? That's talking about the y's. That's in the third and the fourth quadrant. So sine theta less than 0 in the third and the fourth quadrant, because sine refers to the y values. Now, secant of theta less than 0, we know secant is actually 1 over cosine theta less than 0. Well, if 1 is positive, then that means cosine's got to be negative in order for this to be less than 0. Where is cosine negative? Well, cosine is negative, so cosine theta is less than 0 on the left side, which is quadrant 2, and then also quadrant 3. Well, which ones did they share? Well, they share quadrant 3. So we are in quadrant 3. That's an important piece of information to know, because now we can draw our triangle. Let's go ahead and draw my xy axes, and then I can draw the triangle, which looks like so. They tell me sine theta is -3/8. Well, I know sine, the y value of this triangle, is going to be negative, so it's -3. That means this has to be positive, which is 8, -3/8. Remember, this is theta. We always measured off the x-axis. All right, so how do we find this side? Well, we can use the Pythagorean theorem. So let's go ahead and do that. Say c squared equals a squared plus b squared. I know that c is 8, so 8 squared equals -3 squared plus b squared. So 64 equals 9 plus b squared. Subtract the 9, we get 55 equals b squared. Square root it, and we get root 55 equals b. So I know that this right here is going to be root 55. Now, because it's moving to the left, it's cosine. That's actually negative root 55. All right? So we have -3/8, and we have negative root 55/8 for our sine and cosine. And because I just said that, let's go ahead and write these out. So we're going to say that cosine theta is negative root 55/8. Tangent theta is going to be opposite over adjacent, so it's -3 over negative root 55, which gives you 3 over root 55 for an answer. Now, they may want you to rationalize this denominator. If they want you to rationalize this denominator, you multiply by root 55 over root 55, and that will give you 3 root 55 over, when you multiply root 55 times root 55, that's just 55. So this is your answer rationalized. This could be your answer if they accept it unrationalized. We know cotangent theta is the reciprocal of tangent, so we're just going to say cotangent is root 55/3. That's pretty easy. We know that cosecant theta is, we can look right here, 1 over sine. Well, sine is the reciprocal of sine. That's a -3/8, so -8/3 would be what cosecant is. Let's go ahead and circle these. And then finally, we can say that secant theta, we know secant theta is 1 over cosine, and cosine's negative root 55 over 8. So we can say that that is negative 8 over root 55. And we can rationalize that by saying negative 8 over root 55 times root 55 over root 55, which equals negative 8 root 55 over 55. So this could be your answer, or this could be your answer, depending on if you rationalize it. And there's your 6 trigonometric functions.